Hello, kids. Welcome to class. Let's see, adjust that there. Hope that works out pretty good for you. I'm in a different classroom with a different setup this time. Okay, remember the quiz on Friday, 5.1 and 5.3? And there was that one problem, and I was like, this is the geometry review type problem, and then Abby was like, we didn't do this, and I was like, yeah, you did, but then it was different. That was my bad. I'm sorry. I don't know why I was on the 5.1 to 5.3 quiz. I didn't make that quiz, but that is what we're learning in 5.4. One of the things we're learning in 5.4 is right triangle trigonometry. So with right triangle trigonometry, I also think it's weird that they saved this for the last section in 5.4. This is the last section in 5.4, then we're gonna be taking a test. But yeah, so right triangle trigonometry, you might remember this. This is so, ka, toa. And if you remember, this is like, to help you remember, kind of like Sir Zixertykes, but from our geometry here, sine equals opposite over hypotenuse. So the difference between this and what we've done earlier in this unit is the Sir Zixertykes was for angles in standard position, whereas this is for any sort of right triangle. This is the easier lesson, I feel like. All right, so we have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay? And we can use this to solve missing parts of triangles. All right, let's try one. Let's try this one from the book. It's a good one. Let's see, right triangle. I'm gonna give you the following information. First of all, when you're solving triangles, angles are given with capital letters, sides are given with lowercase letters. So if we have the triangle A, B, C, notice how all these angles are named with capitals? Well, the side opposite from A, we'll call lowercase a, because that side kind of corresponds to this angle. The side opposite from C, we'll call lowercase c, little c. And the side opposite from this angle B, we'll call lowercase b. All right, so I'm going to give you the following information. This angle here is 34.5 degrees, 34.5, and this side C is 12.7. 12.7, that's the length from A to B is 12.7. All right, so what are we given here? We're given angle A, and we need to solve the triangle, meaning we need to find all the missing angles and the missing sides. So the first thing I want to find, let's find side A. So if you look at angle A, that's 34.5 degrees, I would describe A as opposite, and we know the hypotenuse. So which of the trig functions will we want to use if I know this angle, I want to find the opposite, and I know the hypotenuse? Look at sine. See how sine has to do with opposite over hypotenuse? So what we would say is we say sine of 34.5 equals the opposite from that angle, which is A, over the hypotenuse's length, which is 12.7. And that sine of 34 is just going to be a number. So we're going to use algebra. We're going to use algebra to solve for A. how would I get rid of this 12.7? I would multiply by 12.7. So I'll multiply by 12.7 on both sides. And then that cancels. So I have 12.7 times sine of 34.5 equals A. And I'm gonna just plug that into my calculator. Make sure your calculator is in degree mode. And I'll go 12.7 times sine of 34.5, and we get 7.2. Decimals are okay in this type of problem. Right triangle trigonometry, decimals are just fine. So this A is 7.2. Now that we know two sides of the right triangle, we could use the Pythagorean theorem if we wanted to. But this trig stuff is so much fun. Let's do trig again. Let's use some more trig. I'm gonna use more trig to find B. I'm gonna find little b now. Little b. So let's see here. I know this angle. This is the adjacent side. B is the adjacent side. Let's use tangent just for fun. You could use tangent because tangent is equal to opposite over adjacent. We could use cosine. Cosine is equal to adjacent over hypotenuse. So let's use tangent just for fun. So I'm going to say tangent of A, or tangent of 34.5, is equal to the opposite, which is 7.2, over the adjacent, and look at 34.5, the adjacent side is B, over 34.5. Oh wait, no, I'm sorry, gosh, crazy. The adjacent side is B. So tangent of 34.5 equals opposite 7.2 over B, which we're solving for. Sorry for that mistake. Glad I caught it before I had to restart the video. So now we're going to solve for B. So I'll multiply by B on both sides to get it out from the bottom. Multiply by B, multiply by B. So I have B times tangent of 34.5 equals 7.2. Now to get B by itself, I'm going to divide by tangent of 34.5, divide by tangent of 34.5, and I get B equals 7.2 divided by tangent of 34.5. And we're going to want to punch that into our calculators just to find out what B is. Make sure you put this entire denominator in parentheses, okay? So tangent of 7.2 divided by tangent of 34.5 equals 10.5. So B is approximately 10.5. And again, decimal is just fine. So one thing you can do is check for reasonableness. With a right triangle, you always need to make sure that your hypotenuse is the longest side, which it is, that's good. And your legs are shorter. I'm gonna give you another thing to check it with. Let's find that last angle. What's the easiest way to find the angle? What do all angles in a triangle have to add up to? You guessed it, 180. So the easiest way to find this angle B is to do 180 minus 34.5 minus 90. So let's try that. 180 minus 34.5 minus 90, okay? 55.5. All right. Now, so you can check your work by applying the Pythagorean theorem, right? So if we did 10.5 squared plus 7.2 squared, it would be really close to 12.7 squared. I mean, theoretically it should be exact, but since we rounded, we're gonna have a little bit of a rounding error issue. So, let's try it. 10.5 5 squared plus 7.2 squared equals 12.7 squared. I'm going to plug that into my calculator. 10.5 squared plus 7.2 squared equals 162.9, and 12.7 squared equals 161.29. And like I said, they're just slightly off just because of the rounding errors. The more precise we took our answers to, the more close this would be. Let me give you another way to just check visually, and I think this is a good way to check too. So, which angle opens up the widest of the three angles? This angle C is 90 degrees, this angle B is 55 degrees, and this angle A is 34.5 degrees. So another way to check is your longest side, which is 12.7 or hypotenuse, is opposite from the largest angle. The smallest angle of 34.5 should be opposite from the shortest side of 7.2. And the medium angle should be the medium length side. See how the opposite angles correspond to the sides? It's just a way of checking. It's really nice. All right, let's take a peek at one where we need to solve for the angles. All right, let's see here. All right, here we go. I'm gonna erase all this stuff. You have the SOHCAHTOA stuff. I'm gonna get rid of it. Oh boy, this whiteboard is I'm using paper towels. All right, that'll work, that'll work. Okay, next triangle. Let's say, here we go, right triangle. Let's call, and typically guys, for a right triangle, we always call the 90-degree angle C. That way, the side opposite from that 90-degree angle is little c. And the other angles, it doesn't really matter. But if you do it like this, then when you're doing, if you do the Pythagorean theorem, you have a squared plus b squared equals c squared, right? Okay. Any questions on, well, I guess I can't answer your questions right now. I'm just used to saying that. All right, so let's give some numbers here. Let's say this is, little c is 53.6. And let's say little a is 29.4. Okay? And I'm sorry, that's little b. I apologize, little b. And do we get any other information? No, that's it. And we have to solve the triangle, meaning we have to find this side, I'm sorry, this angle, and this side. Okay. Which angle do you want to find first? You want to find A? Let's find A first. We don't know A. So let's see, but I do know the adjacent side to A, and I do know the hypotenuse. So which one dealt with adjacent and hypotenuse? You could say sine, because sine is the one with adjacent, no, cosine. Cosine of A is equal to the adjacent side, 29.4 divided by 53.6. And let's see, how do I get A by itself? How do I undo cosine? Well, to undo cosine, you do the inverse function of cosine, which is cosine inverse. Cosine inverse will cancel that, and you'll be left with just a. But if you cosine inverse the left side, you have to cosine inverse the right side as well. So cosine inverse of 29.4 over 53.6. Let's punch that in and see what we get. .4 cosine inverse of 29.4 divided by 53.6 is 56.7 degrees. So for angle A, I got 56.7 degrees. Does that seem reasonable? I think that's reasonable. What if you got something bigger than 90? Would that be possible? No, because this angle here is already 90. Now, what's the easiest way to find angle B? Well, what are they all going to add up to? 180, so I can do 180 minus 56.7 minus 90. And that leaves me with 33.3 degrees for angle B. 33.3. All right, we have one last thing to find. This little a. We could use Pythagorean theorem, but let's practice our trig, right? Practice makes perfect. So let's find little a. We can use, have we used cosine yet? Let's use cosine. So, oh, we just used cosine. But we haven't used cosine to find a side. Let's use cosine. Let's use cosine. So I'm going to use angle B. I'm going to say cosine of 33.3 equals adjacent A over hypotenuse, which we know is 53.6. All right. So to solve for A, I'm going to multiply both sides by 53.6, and if I do, I get 53.6 times cosine of 33.3, and that's equal to A. So 53.6 times cosine of 33.3, and that means A is equal to 44.8. Boom. There we have it. And let's see here. I'm going to go ahead and clean this up. We're already done with this. You can always rewind if you need to go back at the work. And I know that A is equal to 44.8. Okay? Is it reasonable? Look at the smallest angle, 33.3. Is it opposite from the shortest side of 29.4? It is. Let me show you another way to look at this to check that. It's called the good old-fashioned alligator test. I'm going to erase this. I'm going to clean this up a little bit. Let's get rid of all the letters and let's just look at the numbers. This is a way to check to see if everything matches up. The only reason I'm getting rid of all the letters and all the numbers is to try to simplify things so there's not so much clutter on the board. But this is the good old-fashioned alligator test. So you have a triangle, and if you can picture an alligator, I'm drawing, and then we'll give him his alligator teeth. Look at how hungry this alligator is. He's going to eat all 53.6 units of length because his mouth is so wide open. Now, look at the shortest side, the 33-degree angle. Look at this guy. He is not so hungry. His mouth is not open nearly as wide. He is only going to eat 29.4 units of length. And if we do the medium alligator, say goodbye to the least hungry alligator. Here, say goodbye to the hungry alligator. Here will be not so hungry, but hungrier than the other one. He only opened his mouth up 56.7 degrees, will only eat 44.8 units of wood. I hope you liked it. As to review, you learned it all in geometry. But I got some work for you guys to be working on. Try to complete all these problems. We are going to test on this lesson, not on, what's today? Not on Tuesday, not on Thursday, but we'll be testing on Monday, okay? 5.4 is the last section. There's one other part of 5.4 that's kind of new. It just has to do with word problems. But really, this is the basics of the right triangle trigonometry. Now, we've seen it all before in geometry. We accidentally saw it on the last quiz. Let's practice it on Math Excel. I'll be back hopefully at 1:30-ish. We'll see how long the meeting goes, and I'll answer any questions. But for now, get to work on Math Excel. Have a wonderful day.